Okay, let me introduce you the last keynote speaker of the day. We are very happy to have John Holt on board because this ensures that you all stay to the very end. John is a professor of system engineering at Cranfield University, and he's a director of Scarecrow Consultant. I believe there are two topics that are very close to John's heart, and these are MBSE and promoting STEM. If you don't know what STEM is, it's not a problem. I had to look it up as well. It stands for science, technology, engineering, and mathematics. Beside all of this, John is a magician, and he's also an author of a children's book, of course, with the topic engineering. John, the stage is yours.
Thank you. Okay, well, thank you. Thank you for inviting me. All these years, I'm finally here. I finally ran out of excuses not to come, but thank you for inviting me to your beautiful city. Welcome everybody that's here. I think we got 197 people, and also welcome to the at least 2 people who are watching this on YouTube. So if you are watching on YouTube, hello Patty, hello Millie. They're definitely watching. So that's almost 200 people that we now have watching this. Including me. So I'm going to talk, the name of this presentation is a little bit misleading because the name of the presentation is, you can't see that, can you? I can barely see it. MBSE in the slide, but it actually takes me 20 slides to show you how to do MBSE in 1 slide. Okay, but don't worry too much about that. It'll hurt your head if you think about it too much. So as David said, my name is John Holt. I work for Scarecrow Consultants. I've also worked very part-time at Cranfield University, where I'm a professor of systems engineering, and I'm also the current technical director of INCOSE UK. So obviously the UK counterpart to where we are today. So there's a few things I want to talk about, and I was very pleased with the other 2 keynote presentations today. Particularly with what David was saying this morning. So I'm going to refer back to some of the things that people have been saying and hopefully just give it a slightly different spin. There's a slightly different emphasis that I'm going to put on things today. So I'm going to talk about, very broadly speaking, the need for MBSE, and I'm going to talk about complexity to begin with. It's an issue that's been raised a number of times already today. I just want to give you a few examples and illustrate the point of where I'm coming from. Then we'll go on to the completely misleading MBSE in a slide. And then I want to talk about the evolution of MBSE and actually applying this in real life. Now, one thing that I have noticed is my entire career has been MBSE, although it wasn't called that when I started it nearly 30 years ago. But one thing I've noticed is over the years, until about probably 8 or 10 years ago, every time I spoke at a conference, the big argument I was having is you should model, you should model, you should model. And then as of about 8 or 10 years ago, this whole argument has changed because now people accept that you should model. And the question has changed. And the question now is, how do we model effectively and how do we model efficiently? Okay. So, and I think that's an important shift. And so we've seen the maturity of modeling, the maturity of model-based systems engineering is increasing all the time. And we've seen that in some of the applications today. And certainly we've seen it with some of the stuff that David was talking about this morning. So I'm going to talk very briefly about complexity. So if you've done any sort of work in modeling, you'll know the 3 evils of systems engineering, if you like. The things that drive us are complexity, so uncontrolled, unidentified, unmanaged complexity. Communication, so common languages. I'm going to talk about common languages. I'm going to talk about communicating with different stakeholders as well. And also understanding. And by that we mean across the entire life cycle. Clearly, it's very important that we can understand requirements, but it's equally important we can continue that understanding across everything else that we do. So I'm going to talk about complexity to begin with. And essentially, there's 2 types of complexity that we can talk about. There's what's called accidental complexity and what is called essential complexity. So essential complexity is complexity that exists in the essence of the system. And we can't really reduce that because it's the natural complexity of something. We can identify it and we can manage it, but generally speaking, we can't reduce it. But then we also have accidental complexity, and that we can do something about, because accidental complexity is our fault. That's introduced by our people, process, and tools, the way that we do things, and we certainly can do something about that. So we can identify it, we can manage it, and we can reduce that complexity. But I just want to give you an illustration of how complexity is increased by orders of magnitude over the last few years. So my very first car, I don't know if this will mean anything to you. Many years ago, when I first passed my driving test, in the UK, we used to have what's called an automotive industry. Okay, we don't really have one anymore, and we certainly won't have one after October the 30th. But that's another. Don't get me started on that. So my very first car was from a company called Triumph. I don't know if people are aware of that. They make motorbikes as well, and it was one of these. This is a Triumph Herald. It's an incredibly beautiful car. My first car was a 1969 Triumph Herald. It was old when I got it, and it was a joy to drive when it worked. Okay, so the basic requirement for any car is to get you from A to B. Okay, the Triumph Herald usually did A. Very rarely did it get you to B without being towed or being on the back of a truck or something like that. But the basic requirement of the car is to get you from A to B, okay? The interface to the car was a steering wheel, a gear stick, and 3 pedals. That was really the interface to a car. And if you looked at I won't even say electronics on the car, it didn't really have any. If you look at the electrical system on this car, it had lights, okay? It had wipers. In case you don't know what wipers are, that's the universal mine for wipers. And it had a starter motor. And that was it. Okay, so if you wanted to spray water onto the windscreen, you had to press a plunger, a mechanical plunger, and the more force you applied made it shot up the windscreen. That was my first car, and it was an incredible thing. My current car looks a bit more like that. It doesn't look quite like that, but it looks a bit more like that. And the requirement for this car is to get me from A to B. It's the same, okay? The interface to this car is also pretty much the same. It's got a steering wheel, it's got a gear stick, and it's got a gear stick, and it's got 3 pedals, okay? Sorry to confuse you all. And it's got 3 pedals as well. So the interface is the same. The way I drive the car is the same. The basic requirement for the car is the same, but the complexity of the realization of that car is increased by orders of magnitude. On my Triumph Herald, I had lights and indicators, wipers, and a starter motor. This car it tells me off. Okay, if I'm going too quickly, or I'm going across the lines, or anything like, if I'm swearing too much, the car will tell me, and it will stop me doing things. It will stop me from crashing into other people. It will talk to the road system that I'm driving along and then say, you really should be going slower than this in this particular area. It will talk to other cars. It will talk to GPS systems. It will talk to the cloud. It does all sorts of things. I don't even know that it's doing them, okay? When this thing was built, when the Triumph Herald was built, up until probably 15 years ago, automotive was largely about integration. It was about getting components and putting them together, and out comes a car at the end of it. And so it was very heavily siloed. So we'd have the brake system, we'd have the steering system, we'd have the engine, we'd have the gearbox, and so on and so on. And then you plug them together, much like Lego bricks, and out comes a car at the end. It isn't like that anymore, because the boundaries, the silos are broken down, and the coupling between these different elements of the system is completely different now. So now when I put my foot on the brakes, the energy that's generated, the heat, is reclaimed and used in the climate control system. Okay, so where's the interface? Where's the boundary between those two? New interfaces exist that never existed before. New subsystems exist. I've got a thing, I didn't even know it was a word, an infotainment system. Okay, I had a radio in it at one point. I stress radio, not even a tape player, a radio in that thing. This thing has an infotainment system with screens, and you can watch videos and do all sorts of things on it. But that's not actually a real system. The brake system you can visualize, you can pick it up. The wheels you can pick up. The infotainment system is bits from all over the car, kind of brought together into like a virtual system. So the complexity inside this system, inside this car, is increased by orders of magnitude, particularly when we start to talk about things like hybrid vehicles, where we've got combustion engines and electric motors working together. But it's even worse than that, though, because now, as I said, my car now connects to the internet when I'm not looking. It interacts with other road users. It will call, if I crash my car, it will call the police and tell them and do things like that. So it's actually, my car is now, not only is it more complex inside by orders of magnitude, but actually it's part of a truly a wider system of systems, okay? It's interacting with all these other systems that I've got no control over, that it has to interface with to deliver the same the same features or the same capability of the car. But the basic requirement hasn't changed and the basic interface hasn't changed, but the solution, if you like, has increased by orders of magnitude. And that's what we're up against now, okay? Now, this has been happening for years in areas like aerospace, but as the world becomes more connected and as people demand more comforts and more quality in what they're doing, so the complexity of all of our systems is going to increase as time goes on. And as the complexity increases, so does our responsibility as engineers increase to produce better systems that people can trust, that people can rely on. So things like security and safety are now paramount, whereas, let's face it, my Triumph Herald, seatbelts were an option when that thing was built, okay? Security, my filing cabinet key used to start that car as well. So it was, these things just didn't really exist then. So let's move on a little bit. So let's talk a little bit more about complexity and complexity in our systems and complexity in our models. And one of the problems that we have is trying to visualize things. So visualization is a very, very important thing that we can do, because you can visualize these two cars, but what you can't visualize is the complexity that lies underneath these two cars, because you can't really tell from the outside looking in. So what we have to bear in mind is that complexity actually has a shape, okay? And the shape of complexity is that, okay? This is a brontosaurus. This is a dinosaur, okay? Every male in the room, suddenly their faces light up when they realize I'm going to talk about dinosaurs, okay? You weren't expecting that when you turned up today. So this is a brontosaurus, but it's not any brontosaurus. This is the brontosaurus of complexity. It's a very special brontosaurus, because the brontosaurus, as we all know, conforms to the brontosaurus theory, okay? The brontosaurus theory states that a brontosaurus is, let's see if I can get this working, is very thin at this end, it's much, much thicker in the middle, and it's very thin again at the other end, okay? This was defined in 1971. And so when we go through any sort of project or any sort of system, the magnitude, right, stop me if this gets too complicated, the magnitude of the complexity is analogous to the thickness of the brontosaurus, okay? So when we start a project, we're here, we're at the smiley face of the brontosaurus, and if I was looking into the, I'm not tall enough, if I was looking into the smiley face of the brontosaurus, the complexity there is representing somebody giving me a few sheets of A4, some requirements that tells me all about the project, and I read these, and it's written in English, and I read it, and I think I understand it, and so I smile at the brontosaurus, and it smiles at me, and we're both very, very happy. And I do all my cost, time, and resource estimates based on a few sheets of A4 text, okay? And I smile, and it smiles, and I wink, and the brontosaurus winks, and the world is a very, very happy place. Now, unfortunately, some people just stop there, okay? But what I do as a systems engineer, I start to do things like modeling. So I start to scratch the surface and say, well, what did we mean by that? What about the different contexts? So going back to what David was saying this morning, models mean nothing unless we know the context behind them. From which point of view? So I look at all these, and something interesting happens, because the complexity starts to go up. And then I look at things like scenarios, and I do all these, well, what if this happened? What if this happened? Can I make it safe? And the complexity goes up and up and up. And then I get into things like candidate designs. And then I get into things like, the complexity of the actual technical part of the solution. People are using different tools, okay? Some people are using Visio. Some people are using SysML tools. Some people are using, God help us, doors and things like that. Other people are using slightly different versions of the same tool, which means they won't speak to one another in any way, shape, or form. And then the complexity goes up and up and up, and we're here in the belly of the brontosaurus. That's the point where all the contractors in the company get up and leave and go and work for another company, okay? That's also the point where project managers start to look for other projects to go and manage, okay? And it's very frustrating, because you go, well, I've done all the right things, I've done the modeling, but the complexity has gone up and up and up. What's going on? But then something interesting happens, because if we continue to apply these techniques, we hit a point where the complexity starts to go down again, and it starts to go down. So what we have here, we've got a solution to the problem that we had here, but it's big and it's ugly and it's not maintainable and we can't communicate it to people and it's complex and it's difficult to understand. As we start to go down the tail, the complexity starts to go down until we hit this point here, the tail of the Brontosaurus, and what we have there is a concise, elegant solution to the problem that we had here that's as simple as possible, but no more so. It's not overly simplified. It's the right level of simplicity. We can understand it, and very importantly, we can communicate it to all the relevant stakeholders in a language that they can understand, okay? So that's where we want to be. Unfortunately, we can't go from smiley face to tail without going through the belly first. When I talk about MBSE and the techniques I'm going to talk about in a moment, what they do, they make this transition from smiley face to tail as painless as possible, okay? The sort of structured techniques I'm going to talk about are really geared at making this as painless as possible and making the Brontosaurus as skinny as possible, okay? So that's the Brontosaurus of complexity. So that's about the level of this presentation, to be quite honest. People like it though, what the hell? Now, this is where the analogy with the Brontosaurus falls down, because the Brontosaurus, although it's very easy to visualize, even with my drawing skills, never really existed. It was never a real dinosaur. Complexity, on the other hand, is definitely real, but it's very difficult to perceive. See? I thought about this stuff, you know. So let's move on. So when we talk about MBSE, how do we actually implement MBSE? There are three things we need to consider. There are people, processes, and tools. By process there, what we really mean is the overall approach. It's a little bit of a legacy term, that. But very importantly are the lines between these, because we're systems engineers, we apply systems thinking. We never think of things in isolation. We always think about the relationships between things, and that gives us a lot of very, very valuable information. So for example here, the overall approach drives the tool. Tools are essential, don't get me wrong, tools are essential to everything that we do, but we must make sure that we're the master of the tools and not the other way around. What we shouldn't be doing is changing the way that we work because we bought a tool and that makes us change the way that we work. If you work well and you work successfully, the tool should implement that, the tool should help you, it should make it better, it should make it more efficient. Unfortunately, many tools aren't bought in the right way, and people end up changing their basic capability, what they're able to do because of the tool. Also very importantly, we've heard any number of times today about people in the loop. How important are people? So what we mean by people there are, yes, competent people. So people with the right knowledge, skills, and attitude, but also things like culture, you know, people working in different countries, people coming in with different expectations. So for example, in every conference I've ever been to in the world, the last slot of the day is the worst one. Apparently in Switzerland, it's the opposite way around, I've been told by certain people, Mike, that this is the slot of honor, as it were. So, and not the graveyard slot, as it's often referred to. So different cultures, different benefits, different people. So we'll be coming back to this guy in a moment. So people, process, tools, we need all three of them, or we need to get the balance right. And very importantly, we've got to make sure that our approach, the process, drives the tool and not the other way around, and also that our people will enable our approach, they'll enable our processes. We can have the best approach in the world, and if we don't have the people with the right skill sets and the right attitudes, it's worth nothing. Likewise, we can have the best people in the world, but if we can't get them to work together, then it's pointless. Again, we can have a really good approach in place, but we're never going to get any of the efficiencies or anywhere near as many of the efficiencies and benefits unless we've got a good set of tools in place as well. So I'm going to come back to all of these things as we go through in a moment. Okay. So I'm just going to see what we're on. So this is the next 12 slides are MBSE in a slide, but bear with me. Okay. I'm going to build this up slide by slide as we go along. Listen, my entire career is modeling of the MBSE nature rather than the swimsuit nature. But so everything I've done in the last almost 30 years, it's been about modeling. The danger with modeling, one of the biggest dangers with modeling is it's easy to produce information. It's easy to do drawings. It's easy to produce stuff. Just because you've got a big model doesn't mean it's any good. Okay. What you've got to remember at the end of the day is the reason that we're here is the system. to develop, to understand, to do whatever it is to our set. We must never lose sight of that, because it's very, very easy to forget what we're doing in the first place and just produce loads and loads and loads of information that nobody will ever use, nobody will ever get any value from or any benefit from, okay? So we must always remember that that's why we're here, for the system, okay? Right, if there's any objections at this point, I might as well just go home, right? System. We saw this morning, David Long actually said, what's your definition of a model? Thankfully, it was pretty much the same as what we got here. We got this idea of a model that's an abstraction, it's a representation of our system, okay? It's got to be a simplification of our system. That's the nature of modeling. If it wasn't a simplification of our system, it would be the system. We'd just be producing another one, okay? So it's a simplification. There's inherent dangers with that, because we need to make sure that we're not going to lose relevant information, pertinent information, that what we've got. So this, again, this is our start point. We've got this idea of a model that abstracts our systems, okay? When we look at what constitutes a model, we have this idea of views. And I'm going to talk about exactly what I mean by a view in a moment. A view is not the same as a diagram. I'm going to talk about notation and diagrams in a moment. A view is a particular set of information, but very importantly, it has a purpose. We need to know why we're producing this information. We need to know who's going to benefit from that information, which of our stakeholders are going to benefit, and in what way. If you have any piece of information that's being produced as part of your model, and you can't say who is going to find that useful, which stakeholder, and why, what benefits they're going to get, then it's not a view, forget about it. Okay? At every point when we're doing our MBSE, and in fact, when we're doing all our systems engineering, we've got to ask why. Why are we doing that? Who's going to benefit? What's the value in what we're doing? It's very easy to produce information that's got no value whatsoever. We need to make sure that every single thing we produce when it comes to modeling is of value to one of our stakeholders and know exactly what that value is. Okay? Does that make sense? This line here is absolutely crucial. Each of our views must be consistent with the other views, okay? Otherwise, we've just got a big pile of random information. So consistency is king when it comes to modeling. We need to make sure that each one of our views is somehow consistent with all of the other views that we've got. What you've got to bear in mind is not everybody will look at the entire model. In fact, very, very few people will look at the entire model. Most people, or I should say more accurately, most stakeholders who look at the model will be interested in a particular subset of views, okay? But what we need to make sure is that if we've got a stakeholder, say the end user, and they've got a set of views that they're interested in, and then we've got another stakeholder, let's say the maintenance engineer, and they're looking at a different subset of views, those views have to be consistent with one another. Just because we're looking at them from different points of view, different contexts, we still must enforce this consistency between things. So if we don't have that line there, it's not a model. Okay, it's just a big random pile of information. Okay, so every time we produce a view, we've got to be basically saying, what's the context? From which point of view we're looking at this from? What's the benefit? What's the value that somebody's going to get from looking at this? Okay, and if we can't answer that, then we shouldn't be doing it. Right, now one of the biggest, to my mind, misconceptions about MBSE is SysML. Okay, SysML, I use every day of my life. It's a marvelous thing. It's very useful. It's very powerful. But what SysML is a notation. SysML is not MBSE. SysML just happens to be a good enabler. It's a very important part of MBSE, or I should say the notation is a very important part of MBSE, and SysML happens to be a notation, okay? But it's not the same as the model. It's not the same as the view. So SysML has a number of diagrams. Diagrams don't care about who's looking at it. That's just the mechanism. It's the medium that we're using to communicate with the relevant stakeholders. In reality, in any real project, we had a couple of points this morning. People said, oh, but SysML is too complicated. You know, some people don't understand it. No, of course they don't, because not everybody's a systems engineer, okay? But what we've got to make sure is that the notations that we choose are appropriate for the stakeholders who are going to look at them, okay? David made a really good point this morning about text. And he said, or a document, he said, is a document a model? And the answer was yes. And that's absolutely crucial. It's just a different way to visualize. The notation could be structured text, for example, and that's perfectly acceptable as part of our overall MBSE approach. Obviously, if you adopt a good standard notation like SysML, there's lots of benefits that will come along with it. But from an MBSE point of view, to be quite honest, I don't really care what notation you're using. What I care is that you're using that notation to visualize these views and that everything is consistent. One of the things that SysML brings to the table is this consistency between diagrams. If you create views, if you visualize views using SysML and you have consistency, you've got a good chance of visualizing the model. If you use SysML and you have no consistency, you've got a big pile of pictures, and we're not interested in drawing pictures, we're interested in modeling. So again, consistency is key to everything that we do here. So this notation could be SysML, it could be UML, it could be a formal method, it could be something like VDM or Z. We could be visualizing it using rich pictures, we could be using text, we could be using mathematics, we could be using BPMN, UML, any notation, okay? So from an MBSE point of view, we don't really care. Ideally, we don't want too many notations there, but we want the notation to be appropriate for whichever stakeholder is going to be looking at it. So visualization is a very important part of MBSE, but there's this idea of just using SysML for everything, although it's a nice idea theoretically, isn't practical in the real world. Different people speak different languages. You have to make sure you can communicate with them in these different languages, okay? So I'm going to come on to another problem that we have in a moment, and it's that of a common language. And we've heard a couple of times today, oh, everybody should speak a common language. We should have this communication mechanism. And if we all speak the same language, then we won't have any communication issues again. That's kind of true. It's a good idea, but just getting everybody to speak SysML isn't going to solve that problem. That's like me saying, everybody speak English and we will never miscommunicate ever again. Okay, and again, this came up, David brought it up this morning. We need the spoken language. So English, for example, is a spoken language. It gives us the basic mechanism that we need to communicate with one another. It's essential, okay? But again, I think the example you used this morning, David, was function, wasn't it? And it was get a group of people and say function. If you work for BAE Systems, a function means a department, a working department. If you talk to software people, it means it's a bit of software. Chemical engineers, a function means something quite different. Mathematicians, it means something different. If you ask me, I think I'm going to a party if you talk about a function, but that's just the way that my mind works, to be quite honest. So we also have this idea of a domain-specific language. So when we talk about a common language, there's two aspects. There's the spoken language, English, and there's the domain-specific language. This is what I mean by function. This is what I mean by requirement. This is what I mean by capability, and so on, okay? We need both. SysML is the spoken language. SysML is the equivalent of saying, let's speak English. We have to do it, okay, or we have to have a notation in place, but it's not going to give us the domain-specific language coming out of the box. And so this is where we're going to move to the left-hand side. In a moment, I'm going to start to talk about ontologies, or whatever you want to call them, meta models or whatever. So the other issue that we need to address is it's actually quite easy to produce SysML diagrams. Are they of any use to anybody, though? This is why we need to make sure that they're visualizing views and they're not just diagrams for the sake of diagrams, okay? But also, in the real world, we'll be working in teams. We'll be working with different clients. We'll be working in different countries. We want to make sure that there's some consistency in, for example, presentation. There's some consistency in terms of the structure and content of each view. And very confusingly, I'm going to use the ISO term. We have this idea of viewpoints. Okay, so a viewpoint basically defines a template for a view. If you were using Word, for example, and you wanted everybody to create a document with the same look and feel, you'd give them a template. It's the same thing here, but what we call a template is what we call a viewpoint, okay? The way that we make sure all the viewpoints work is we have this idea of an ontology. The ontology is the domain-specific language. That's the thing that's going to say, this is what function means and how it relates to requirement. This is what requirement means and how it relates to capability. This is what capability means and how it relates to mission, and so on, and so on, and so on. So to have a common language, we need two aspects. We need the spoken language and we need the domain-specific language. The spoken language is there. It's on the right-hand side. The domain-specific language is here. It's on the left-hand side. Conceptually, they're different things and we need both of them. So one of the easiest mistakes to make in MBSE is just to say, well, just everybody adopt SysML and we'll all speak the same language and all our communication issues will be at an end, okay? So it's a really important thing to get right. Also, when we put these two things together, we call it a framework. So people talk about things like architectural framework, process framework, requirement frameworks, all these sort of different frameworks. That's what we mean by a framework. So when we talk about the approach, the framework is going to give me the different sets of information, the templates in terms of viewpoints that will allow me to create views, and the notation is going to allow me to visualize these views so that I can communicate to the different stakeholders in the way that they expect to be communicated with. What a framework doesn't tell me is how, in what order to do things. A framework will define a number of views, but it won't say start with this view, then do this view, then do this view. That's the job of the process set. So we can have the same framework that's actually being used in different ways for different types of projects, different levels of rigor, different teams of people who are following different processes, but we can have the same underlying framework and the same underlying ontology and viewpoints, okay? And that's a very important thing to get across. Let me categorize these things now. So the way to think about this is to press the right button to begin with, like that. So on the right-hand side, I've just called that visualization. So that's what that's what SysML, UML, all those things are about visualization. It's essential that we're able to do that, and that's what SysML is bringing to the table. This stuff here, the system, this is our goal. We must never lose sight of the fact that this is our job, okay? Anyone that was in Jim's presentation immediately before this, Jim was talking about the execution of things and saying, remember our job is to execute projects and deliver things. That's what we're talking about there. And what we're really talking about here is the overall approach, okay? What are the information sets we need to produce? How are we going to do that in terms of the processes and so on? Okay. So this is what we call sort of MBSE in the slide. And just to disappoint you even further, you might think, well, it's a bit of a trick because there's lots of slides that have gone to build up this one. We've also got MBSE in the slide and a bit as well added onto it. And what we've added on here are two extra things. We've added on implementation here. So we see we've got tool there. And we've added on standards here. So compliance, best practice, whatever we want to call it. Because two of the other really important issues that we've got are tools. We said people, process, tools. Tools are essential to everything that we do. And there's a couple of ways that we can use tools. There's more than this. This is just a very broad stroke overview. One is the tools will allow us to implement our notation, or any number of different notations. But also, if we get a good tool, the tool will also allow us to implement our framework, for example. We can build the framework into the tool. So if you're using something like SysML, it'll be what's called a profile. So you can actually get the tool to speak your language and to enforce the approach that we've been talking about. Okay, so it's a very good way to shorten the learning curve. It's a very good way to make sure that people are producing things in a consistent and coherent and rigorous and repeatable fashion. The top here, we've got this idea of compliance and standards. At the end of the day, when we're working on real projects, standards, legislation, all these kinds of things are going to be massive constraints on what we do. We have to demonstrate to the different stakeholders, whether they're enforcement bodies or standard bodies or end users, that we comply with all the relevant standards. And that's a really good area that we can embed this into our model. We can apply MBSE to the standards. We can model the standards, embed them into our model so that when we start new projects, actually all the compliance comes for free. And it's a very, very powerful way to be able to do things, okay? So when we talk about MBSE, these are some of the things that you've got to consider. And this is the result, very embarrassingly from my point of view, this has been the conclusion of my career after almost 30 years doing this, comes down to one diagram, which is shocking in a way. If you see how much I charge people per day, this is outrageous, that this is essentially my job. But it's really important to do that, and also conceptually to separate these things, because if we have a good approach in place, we should be able to use it with any tool within reason. So again, it's making sure that we drive in the tool with our approach rather than the other way around. If we've got a good approach in place, we should be able to use any notation, okay? And these aren't just like the static sort of models we're talking about, like SysML and so on. We can also introduce things like simulation there, formal methods, all the sort of mathematical analysis and so on. It's a different notation, different tools are being used to do them, but they should comply with our underlying framework. And so we've spoken about MBE a number of times today, model-based engineering, where people tend to do things like electrical diagrams were mentioned earlier today, thermodynamic diagrams were mentioned earlier today, simulations have been mentioned earlier today. Although they're not usually what we think about in terms of MBSE, they've got to be represented in our framework because we've got to make sure that these views, whether they're simulation views or electrical views or thermodynamic views, are consistent with all of the other views, right back to our requirement views that we've been dealing with. So even if we've got very different tool sets, very different notations, the thing that ties it together, the underlying rigor, is coming from our approach. And in that, very importantly, is the framework, which has got our ontology, our domain-specific language, and it's got the definition of our viewpoints. Another point that was raised earlier today is, well, when it comes to things like ontologies or whatever you want to call them, they're a good, don't start from scratch. Look at what's out there. There are good generic ontologies that you can use and you can tailor. That's going to save you time. You know, reuse of models is a very powerful thing to be able to do. So that's the rather misleading MBSE in a slide and a bit that we're talking about. So my main job is I go into organizations and I help them do this kind of stuff, and I help them look at this. And this is a good start point, actually, because you can say, actually, in your organization, which of these are you strong on? So we get into some organizations and they've started on the right-hand side, okay? And they've started with tools and they've bought tools and given them to people. And then they've said, these tools, we're not getting any of the benefits from them, therefore MBSE doesn't work. But what you've got to say is, no, if all you've done is that bit there on the right-hand side, what about all this stuff? Okay. Likewise, we go to some organizations where all they've done is taken off-the-shelf frameworks such as DODAF and MODAF and NAF and all these sorts of things, and tried to apply them blindly without tailoring them. So again, well, you haven't thought about what it is you're setting out to achieve in the first place. You haven't thought about the notations. So it's a good way to sort of look at this diagram and say, well, where do you live and where's your capability at the moment? Where are the gaps on there? And what's important to you as well? Okay. So after many years of doing this and then going into different organizations, we sort of came to the conclusion that customers we've already established are always right, except for when they want something completely unrealistic and unfeasible, which is most of the time, really. So I'm going to talk about the evolution of MBSE, because what people say is, oh yeah, we want to employ MBSE, we want it in place next week, and we don't really want to spend any money doing it. And we don't really, want to spend money training people or paying people to come in. And you can't do that. Okay, so this is what I'm going to talk about now for the last bit of the presentation, is the evolution of MBSE. And when you think of evolution, I think about, the picture with like caveman, and then he gradually gets more and more tall and so on, and turns into a human at the end. So we've obviously stolen that and replaced him with a Lego man. It looks like that. Okay, so this is the evolution of a very good-looking Lego man, by the way. We've replaced him with the Lego man, and we've just kind of made these up. Okay, based on our experience of doing this for many, many years. And again, it's just a guideline. It's just to get you thinking about how to employ MBSE in your organization. And so we've just introduced 5 stages there, what we call document-based, document-centric, model-enhanced, model-centric, and model-based. Change these terms if you want to, it doesn't really matter. So what we've got at each point in one of these stages, we can look at the different people and process and tools aspects and say, what are the typical levels of people and process and tools that we have at this stage? So let's look at each of the stages. So what I'm going to say now is that each stage has a number of outcomes associated with it in terms of people, process, and tools. This is the first stage, which is document-based. So we've got a big pile of documents there. Text is, you probably can't read that. It says the Lego man, head, the chest, arms. In terms of people, we want them to have some sort of systems engineering competence. They're not necessarily MBSE, but certainly that. In terms of the approach, the process, all the artifacts are documents. So this is coming back to what we were talking about earlier about getting away from this idea that, these very document-heavy things of artifacts. We might have tables, lists, graphs, and so on. And typically speaking, the tools that people will be using with things like office tools, spreadsheets, Word, PowerPoint, all these kinds of things, okay? And before I go any further, there's nothing wrong with that, okay? If you were building my Triumph Herald car in 1969, that would be fine. There'd be nothing wrong with that. It would be fit for purpose. People have done this for decades and it's worked. What's happened now, though, is we're no longer building my Triumph Herald. We're now building my new Citroen. And this won't work for my new Citroen because it's too complex, okay? So we're not saying this is bad. What we're saying is it's no longer fit for purpose when we think about the complexity of the current systems that we're dealing with, okay? So let's go on to the next stage then. So here we got what we just call document-centric. We start to see pictures evolve from things. So here we see the little Lego person coming out here. We've got, again, people with systems engineering competence, but also things like informal notational skills. People might be doing a bit of UML, a bit of SysML or whatever, a bit of structured text or whatever it's going to be. The artifacts are still mainly documents, but we're starting to see pictures emerge, and we might see drawing packages start. So a lot of people still use Visio at the end of the day, no matter how much we might sort of deride them, or well, I certainly do, and ridicule them. There's nothing wrong with that if that's fit for your purpose, okay? So if all you want to do is draw some things and enhance your documents visually, then that's perfectly good, okay? What we start to see now is we start to see what we just call model enhance. We start to see the model sort of emerge from the documents. But notice here, quite often when we start, it's kind of the Brontosaurus effect again. We start with our document heavy system, we move into document centric, and we actually see that the pile of documents starts to increase. There's actually more information there, the documents are bigger and so on. At this point, we actually start to see that pile go down because the true model is starting to emerge, and we're starting to have people who are competent in using the different notations in SysML. That's going to bring you value immediately. Okay, but we need them to be MBSE aware. We need them to understand, for example, MBSE in the slide. The models start to emerge. We start to see documents and models coexisting, and we start to apply it on things like small pilot projects or small isolated parts of the organization. And typically at this point, and I stress typically, we'll have multiple candidate tools. Okay, sorry, I didn't bring my watch with me, so I have to keep looking at what the time is on there. We'll have multiple candidate, saying that, I didn't even look at what the time was then. Multiple candidate tools. Oh, gosh. And to think I was secretly laughing at Clement earlier for his inability to press that button, and I'm the same. So model-centric, MBSE competence. So the model's really starting to emerge now. We're starting to see the ontologies, the frameworks, the processes, the approach is starting to be put in place. Very importantly, we're starting to measure and assess things. There's no point doing a pilot project unless we can assess, has it been successful or not, okay? Tools, we might have selected a tool, we might have selected multiple tools. And step 5, the model-based one, we're starting to see MBSE competence, mature ontologies and frameworks, patterns have been mentioned a few times, applications have been mentioned, and rollout across the company, integrated tool sets, profiles, so tailoring the tools, and so on, okay? As we're doing this, as we're evolving, there are certain things that we need in place all the way through, things like configuration management, consistency, traceability, and maintenance, these cross-cutting capabilities that we need to have in place to make our model evolve properly and be able to track the trends of our model, okay? Now, just to finish, I'm going to have a little bit of a rant at people now, just not like me at all. But what happens is we must transition between these things, and certain things must happen. So, for example, to go from stage 1 to stage 2, you really need to assess where you are in terms of your MBSE capability. And also, very importantly, you need to say, well, why are you doing it in the first place? Because if you don't know why you want to do MBSE in the first place, don't do it, okay? There's no point. If you don't know why you want to do something, how on earth are you going to demonstrate to somebody that you succeeded? Okay, you can't. Understand why you want to do it. This idea that you get, oh, these are the benefits of MBSE. Well, it depends on who you are. It's context dependent. Different stakeholders will get different benefits depending on what it is they want to get. So identify why. We've also got things like MBSE by stealth there. We do this all the time. The use of SysML, you don't need to use all of SysML. We use SysML all the time, and in many cases, we just don't tell people what it is, and they understand it, okay? We use a simplified version, but we just don't tell people, and they seem to understand it because it's squares and lines. To go from stage 2 to stage 3, things like notation training are important, tool evaluation are important, 3 to 4, things like MBSE training, process definition we're going to want, tool selection, tool training, framework and ontology definition, and obviously advanced applications, competency assessment, model maturity, process maturity, tool. So again, measuring these things, feeding them back in. What happens in my life is I'll go to different organizations. They say, we want to do MBSE with no, and then they'll say, oh, and by the way, and Tim Valkins is largely to blame for this because he wrote a book on variant modeling, which is a very good book, by the way, which we use. And then people go, oh, we want to do variant modeling. Can we do that, please? And you say, no, you can't do that because you're here, right? Variant modeling's over here, right? You can't do that because you simply don't have the capability in place. It's literally trying to run before you've even crawled out of the documents, okay? You can't do it because you don't have the capabilities in place. One of the reasons this works is if you can identify where you are on MBS in the slide and then where you are in terms of this evolution, then you've got a very good way to actually look at your way forward. Look at how do you start to go and implement MBS in your organization. But bear in mind some things like variant modeling sit on the right-hand side. Other things like just using SysML are far more towards the left-hand side. So, and we're not saying this is carved in stone, but this is just to give you an idea that things have to evolve. And with evolution, then different activities and different outcomes will exist at each stage. Okay. So just to conclude then, we need MBSE because the existing approach, the document-based approach, simply no longer work. They worked for my Triumph Herald. They don't work for my new Citroen. Okay, it's a pragmatic need. We're not doing it to show off. We're not just doing it because it's the flavor of the month. Okay. Key parts of MBSE include, if you remember, we had the visualization. Okay, so that was the notation part of things. We had the system part, which was the model and the views. And also we had the approach part, which was the frameworks, the ontologies, and the viewpoints. We have to consider those things. And we also have to bear in mind that there is a natural evolution of applying MBSE in your organization. And if you can get even a very high level handle on where you sit here, why you want to do it in the first place, where you sit in terms of MBSE in the slide, and where you sit in terms of the evolution of MBSE, then you've got a good chance to have a way forward. Okay. So that concludes my presentation. I'd like to thank you all for coming and for staying so late. I'd like to thank you all for listening, and I will happily answer any questions that we have. Thank you.
Questions?
Yeah, thanks, John. Can you elaborate on the idea that the views are a composition, or that your model is composed of the views? What happens if you have the same element on different views, or is that not an idea?
Absolutely, yeah. Naturally, you're going to have the same element on different views, maybe visualized in different ways. So, for example, take a requirement. You might visualize that in SysML using a requirement block. Okay, that same requirement might be visualized on another diagram, on another view, using just a normal block. A stakeholder might be a block in one diagram, might be an actor on a use case diagram. Okay, it might be, we might even be using a completely different notation to visualize that same element. So the very nature of the consistency, one of the ways you can think about consistency is the same element appears on different views, maybe visualized in different ways. That automatically gives you a consistency check. So yes, absolutely. Bear in mind, the more questions you ask, the later you're going to be able to leave.
Could you just show slide 32 again, please?
Let's have a look. Yes,
Thank
I
you.
can. Next question.
That slide might suggest that the engineering efforts might become leaner if you go that path to the right.
Yeah.
On the other hand, I think the organizational burdens, I mean, implementing it, training, etc., are growing, which means also the costs. So I would assume if we discuss, we should not just be chasing somehow these ideal on the right.
Yeah.
We must really judge where's the break-up point.
Absolutely, and that's another reason why you've got to identify your goals at the beginning, because cost is in almost all cases a big issue and one of the biggest constraints. And so it might be, you know, oh, we want to do variant modeling. Well, you simply don't have the budget because to do that, you need to get this far. And so very often when we deal with people, what we're looking at to begin with is basically, what's the budget for this project? How are we going to demonstrate it's successful? What can we put in place for that amount of money? And what's the success criteria? So yeah, absolutely right. But as I said, it's just a broad guide, really, you know, write on whatever word you want to. But yeah, very good point.
Thank you very much for the talk. Are you essentially saying that we don't need MBSE 2?
No, not at all.
Nope.
So I'll be completely honest. Until about 2 weeks ago, I wasn't even aware of MBSE 2 because from my point of view, right, there we go. For example, SysML 2, which is one of the things that's feeding into it, sits over here. Okay, so conceptually, it's not irrelevant, but conceptually, this diagram doesn't care whether you're doing MBSE 2, whether you're doing Industry 4.0 in SysML or whatever. Obviously, when it comes to doing this properly, you're going to need to take those factors into account. Because the other thing is, you can bet that when we go to SysML 2.0, all the case tool vendors will suddenly have a big swanky new version of their tool that would possibly be more expensive, who knows, and certainly new training courses and those sorts of things. So coming back to the point we had earlier about, well, actually, what are the costs of these things? That's something you're going to have to factor in. Do you want to go to SysML 2, or are you quite happy with what you've got at the moment? Can you afford to go to SysML 2? Yeah, so to answer it very quickly, this doesn't care whether you're talking about MBSE 2 or not. I think because what I've got here is a very different pitch from what David was saying earlier. It's the same, I think it's fair to say it's the same core concepts, but with a different spin put on them. I'm talking a lot less about specific technologies and specific solutions, whereas I think it's fair to say, David, you were talking more about the future of particular solutions to achieve this stuff. Okay. Does that answer your question?
Okay, thank you. Thank you.
Oh no, here we go.
Now, I just wanted to ask you if you have thought about the MBSE in a slide to make it a children's book as well, because this would help me a lot to explain it to managers.
Well, strange you say that, because normally the last slide's got almost 15 of my books. Buy them all, get a free shrine. Christmas isn't that far away, so start buying now. But we have the big book that's 1,000 pages long. That's for engineers. We have the one that's 50 pages long, which is the Don't Panic book. That's for managers. Okay, and then we have the children's book that's for 8-year-old children and board members. Okay.
I'd like to have that one. Going back to the diagram there.
Which one?
And, so if we look at the mailbox system, so you have the model abstracts the system, so reality and the simplification. You also see that the model can help to develop the system, architecture, and so on.
Yeah, absolutely. So again, it's knowing why you want to do it. So sometimes we'll be creating the model in order to develop a system. Other times we'll be creating a model in order to understand an existing system. So yeah, absolutely.
Okay. Yeah, over here.
All right. Okay.
Thanks again for this wonderful presentation. So my only question is, what did you want to tell us by the missing left hand of the Lego mannequin?
The missing left hand? I didn't even realize there was a missing left hand of the Lego man.
So there's no missing requirement or something?
Yeah. Everyone's a critic, aren't they, today? So I look forward to seeing your Lego representation. Now, that's me not telling the artist that I wanted two hands. Here's me assuming that people would think it's got two. So, but you know what they say about assuming? Never assume. Makes you look like a dick. Okay.
Yeah.
Okay.
Thank you for the presentation again. Can you go back to the MBSE in one slide?
That one?
Yeah. There is an international standard which is called architecture description.
Yeah.
It's 42 ISO
42010. Yeah.
I couldn't avoid see a lot of similarities.
Yeah, because I'll tell you why. Because everything that we do in MBSE, we can demonstrate complies with best practice. So this stuff here is just best practice, essentially, and it fully complies with 42010 and a number of other standards. Because what I don't want to do is stand up and say, oh, look at this, isn't this great? And people say, did you just make that up? And say, well, some of it, yes. But actually, most of it, no, it is compliant with international best practice. So in a quite surreal way, that's this thing here. So this slide here is a view. Okay, in MBSE, this slide is a view. And this view is consistent with our framework that we have, a thing called FAF that we use to define views, and the standards, some of the standards that we apply to, one of them is 42010. ISO 42010.
Okay, but my question, in fact, was there are a lot of similarities regarding with architecture, and I was wondering if this definition of MBSE in a slide is too much architecture oriented and not enough covering other life cycle stage of, other topics that are covered in, I will say, systems engineering, not only model-based systems.
Yeah, I can answer that in a few ways. So when I do this presentation for architects, so I've done this for the ISO committee that does 42010. What I do, don't tell them I've done this, I change that word model to architecture and it still works. And it keeps them happy, okay? Again, it's this visualization and talking the right language, because in my mind, every architecture is a model, not every model is an architecture, okay? You're absolutely right. On here, we haven't got the concepts of life cycles and so on. If you were to look at our big model, which if you buy all 15 of my books and get the free shrine, you can do, you would see that that is covered in the bigger model. It's just not within the scope of this presentation. But yeah, so, okay, thank you. Okay. People want to go home. That's good. That suits me. Thanks very much. Thanks, David.